In this video, we're going to learn about simplifying rational expressions using addition, subtraction, multiplication, and division. We're going to start by looking at multiplication and division. And one thing that we take a look at with these is going to be the greatest common factor. So if we have 8 over 12, we can simplify this by remembering that 2 times 4 over 3 times 4 is the same thing as 8 over 12. They both contain this 4 right here, which means that since we have it in a fraction, top and bottom, we can actually cancel those out. So we can simplify this fraction from 8 over 12 down to 2 over 3. And we can do the same thing with algebraic expressions. So say for instance we have x minus 3 times x minus 1 all over x minus 5 times x minus 1. Because these items are in parentheses, they count as the individual unit, similar to like if we have 2 times 4. So if you notice here, we have an expression of x minus 1 and x minus 1. We can cancel those out because they are a similar item that is multiplied on top and bottom. And so we would get an answer of x minus 3 on top over x minus 5. Now we cannot simplify this out any further. For instance, we cannot separate the x's and the 5's because this expression has an addition sign on top and bottom. This will only work when we're dealing with multiplication. For instance, if we have a number out in front like this that's individualized, or we can put that number in parentheses, versus x minus 1, which we can again put in parentheses, and it's multiplied across the different items. Now say for instance we're given this expression. We still want to use greatest common factor to simplify this expression down as much as we can. So what we have to do is we're going to have to use a technique like diamond method on some of these answers to actually simplify this into individualized fractions. So if we look at the top, x squared plus 4x plus 3, we can use something called the diamond method, where we put 3 on top and 4 at the bottom. And we're looking for a number that multiplies to 3 but adds to 4. Well, that's going to be 3 and 1. 3 times 1 equals 3. 3 plus 1 will equal 4. So now we can take that information and actually have some simplified items within our parentheses. So we'll have x plus 1 and x plus 3, which correspond to those two values that we find. It'll be an x followed by a plus and then the number. If it's negative here, then it'll be negative for the plus sign. Now we can also do the same thing to this x squared minus 9. What is the number that multiplies to negative 9 but adds to 0? These are also called perfect squares, meaning that we actually have an answer of 3 and negative 3. It cancels out that single 1x variable inside because that will equal to 0. And we see that the square root of 9 will equal to 3. So we'll have x minus 3 times x plus 3. Now we can simplify this information from here. We have an x plus 3 at top and at bottom, and those can be simplified out. So this would give us an answer of 5x times x plus 1 at top over x minus 6 times x minus 3. So we can also do this with multiple variables. And in this case, what we want to do, since we have w and y, is find ways to remove either w or y within these parentheses to simplify this down as much as possible. So for instance, we'll notice that in this parentheses, we have one case where we have a w and we have another w here. So we can actually factor out a w, where we get 4w minus 3y times w plus y, all over 3y minus 4w, 5w plus y. Now we'll notice in this case that we have a 3y minus 4w, and here we have a 4w minus 3y. What we can end up doing is factoring out a negative 1 from here. And by doing that, by factoring that out of that negative 1, we change this from negative and this to positive. So this will end up leading to where we have a negative w. Since we flip this, we have 3y minus 4w at top times a w plus y all over a 3y minus 4w in parentheses, and then in parentheses 5w plus y. These two are the same at top and bottom, and now what we're going to have is a minus w plus y, all over 5w plus y. Now, using multiplication and division, we can also simplify complex fractions, where we have fractions inside of fractions. So when we see this, we can think of this as a single unit with a division sign. So we can change this to a plus b over 4 divided by a squared minus b squared over 4. Now with this division sign, we can change this by multiplication by flipping the reciprocal of that fraction. So now with multiplication, we'd get 4 on top, and then a squared minus b squared on bottom. Now this can be simplified out because it is a perfect square. So we'll have a plus b over 4 times 4 over a plus b in parentheses times a minus b. Since we have a 4 and a 4 top and bottom, those can cancel out. And then the a plus b on top and bottom can cancel out. So we're going to be left with 1 at the top because we canceled both of our items out. We're left with 1. And then on the bottom, we'll have a minus b. Now moving on to addition and subtraction. Whenever we're dealing with those, we want to figure out something called the least common denominator, meaning that we have to have a number that we multiply top and bottom of this expression and top and bottom of this expression, so we can get the denominator to be some number that we can actually add together. Remember that our denominators must be the same for us to be able to add the full expression together. Now when we do it with numbers for least common denominator, we're looking for multiples that add up to the same number. And so in this case, we actually have this instance where we have a pairing of numbers and then we have two numbers that have individual components. So we multiply that all together with that pair consisting of one value to get that 18 would be our denominator. So in this case, we'd be multiplying this number by 3 to get 18, top and bottom, and this number by 2, top and bottom, to get 18. This will give us a value of 15 plus 8 over 18 for both of those fractions. And now that our denominators are the same, the number at the bottom, we would just add the two top numbers together over 18. Now we can do the same thing with polynomials and rational expressions. We notice in this case that we don't have the same denominators, but they both consist of this x minus 1. So our least common denominator in this situation is going to be where we have 2 times x minus 1 times x minus 2. All the components that we see in both of these fractions. Meaning that we're going to have to multiply this expression by x minus 2 on top and bottom, and we're going to have to multiply this expression by 2 top and bottom. When we do that, we're going to get 6 over 2 times x minus 2 times x minus 1 plus 5 times x minus 2 over 2 times x minus 1 times x minus 2. Now that those denominators are the same values, we can add just the two top values together. So we get 6 plus 5 times x minus 2 over 2 times x minus 1 times x minus 2. We would need to simplify everything out on the top here. That's going to give us 6 plus 10x minus 10, which would simplify to 10x minus 4. All over our denominator now. And what we can do is we can simplify out a 2 here at the top. So that's going to be 2 times 5x minus 2 all over 2 times x minus 1 times x minus 2. We can factor out a 2 on top and bottom, so our final answer is going to be 5x minus 2 over x minus 1 in parentheses times x minus 2. We can also use this to solve complex fractions. Now we want to see again these items in single units that can be divided upon. And then what we're going to do is the same trick where we change this to multiplication. However, we can't do this with a reciprocal just yet because we need to put this with a single denominator on bottom for this fraction and for this group of fractions. So if we take a look at this one, again we have 1 plus 1 over x. This is going to be the same as x over x plus 1 over x if we multiply top and bottom by x. So that's going to give us 1 plus x over x. And again, we're going to put that right here. Now we can do the same thing for this fraction where we have 1 minus x over y. This is going to simplify to y minus x over y and over y, which simplifies to y minus x over y. Now we want to plug that back into here, but this is multiplication, so we're going to have to take the reciprocal of this. We're going to have to flip this. So now we have y on top and y minus x on the bottom. Now we can multiply these items, both top and bottom. So we multiply just straight across, so we'll have 1 plus x times y over x times y minus x. Multiplying that out, we're going to get xy plus y at the top, and then xy minus x squared at the bottom. Now we can use this information to solve word problems. So for this one, we have a machine can complete a job in X hours. A newer model does the same job in X minus 3 hours. Working together, they finish it in 2 hours. What are the completion times of each machine if working alone? So we have to see this information in terms of a fraction, where we have work rate is going to be equal to 1, which is a completed job, over the time. So that gives us two fractions of 1 over x plus 1 over x minus 3 for those two machines. When we write this as an expression, we're going to say for it to complete one job takes us 2 hours to complete. Now we can move this 2 to the other side and simplify these two fractions into a single fraction. We would have 1/2 is equal to 1 over x plus 1 over x minus 3. We would multiply top and bottom of x on this fraction and x minus 3 on this fraction. And so what we're going to get is x minus 3 plus x over x times x minus 3 is equal to 1/2. Now that fraction will simplify to 2x minus 3 on top and then x times x minus 3 at the bottom. If we look at this information right here, we can do cross multiplication on both sides, and we're going to get that 4x minus 6 is equal to x times x minus 3, and that's equal to x squared minus 3x. We can move all this information onto the other side to solve for 0, so we get that x squared minus 7x plus 6 is equal to 0. Using the diamond method to solve for this, we'd have what multiplies to 6 but adds to negative 7, and that's going to be negative 6 and negative 1. So we're going to get that 0 is equal to x minus 6 times x minus 1. So that gives us two values that x is equal to 6 and x is equal to 1. So if we say that a machine takes x hours and a newer model takes x minus 3 hours, we need to figure out which one of these two equations to plug in. Well, if we plug in 1 into this, we'd get that x is equal to 1, but then that x is equal to 1 minus 3, which is equal to negative 2. So that can't happen. So our answer is going to be that it takes the first machine 6 hours to complete, and then the second machine will be 6 minus 3 hours to complete, which is 3 hours.